is related rate. Related rate problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time. So here's a sample problem. Suppose you have a snowball having a diameter of 6 feet. It stopped growing and started to melt at the rate of 1/4 feet cube per minute. Find the rate at which the radius is changing when the radius is 2 feet. That problem involves related rates. So here's the solution for that problem. There are 3 steps to solve the problem. First step, identify the given and identify what is asked. The diameter of the snowball is 6 feet and the rate of melting is 1/4 feet cube per minute. What will be the rate when the radius is 2 feet? Second step, identify what equation or formula must be used. Since snowball is a sphere, then we must use the formula for the volume of a sphere. Third step is the solution. First, write the formula in finding the volume of the sphere, which is 4/3 pi radius cube. Next, we are given dV over dt equals negative 1/4 feet cube per minute, and we wish to find out dr over dt when r equals 2. Third, now the relationship between the variables is given by the volume of the sphere, V equals 4/3 pi cube. Observe that by the proportionality relations, we obtain dV over dt equals d over dt quantity 4/3 pi radius cube. Next, differentiating both sides with respect to t, we obtain dV over dt equals 4 pi radius squared dr over dt. Then substitute the value of dV over dt, which is negative 1/4, so we obtain negative 1/4 equals 4 pi radius squared dr over dt. Sixth, simplify, then here we have dr over dt equals negative 1 over 16 pi radius squared. Substitute the value of r, which is 2. Then we obtain dr over dt equals negative 1 over 16 pi quantity 4, or negative 1 over 64 pi feet per minute. Therefore, the final answer is negative 1 over 64 pi feet per minute. It is in negative form since the snowball is melting and it is decreasing.